So I am in my IntelliJ in the presentation mode, and let's start solving this problem. I will take the same function name, method name as given here in lead code. Mark it as final, and let's start. Yeah, so first of all, as we have noticed that we need to check the sum of all the numbers, and if the sum is an odd number, then we have to immediately return as false, because if it's odd, then we have already discussed that we cannot partition it into two equal subsets having equal sum. So let's do that. Let's first of all, yeah, but before that, let's do one more base case, that if the nums dot length is 1, right? In that case, it will be always false, because if only like one element is present, then we cannot divide it into two subarrays. So let's check for this base condition first. If then immediately return false. Now let's go with the sum approach. We need to find the sum first. So it's quite easy right now using Java, using the arrays stream. The stream API is very powerful. We just need to use nums.sum. Okay, that's it. This sum will reduce it. Use the reduce function at the back, and then starting with 0, and then calculate the sum of the whole array. And now we need to check if sum is odd. For that, I will take the modulo, and it's equal to 1. It means that it's an odd. We have to return false immediately. Right. Okay. Now let's proceed with our dp approach that we solved. So we need to create this dp of set, starting with element 0 only. It would be only 0 first, when we don't have any element. And once we get the first element, we add to whatever is there in the set it's already, and compare that whether we have reached the target of sum by 2. So first of all, let me create a set, which is our dp. I'll just use normal hash set. Nothing fancy here. And let's the first base element, when we don't have any element, then the sum is 0 when we don't choose any element from the nums arrays. Now let's see the target that we have to achieve is sum by 2, right? And now we just iterate through each of the numbers in the nums array. Let's do it right here to save some space. Okay. Now we go through each of the element and add with whatever. For the first element, it's only 0 there, so it would be just adding 0 to it, and now the number itself. So okay, but before that, once we are iterating through this dp, whatever the numbers are there in this dp, okay, let's do that first. Let's iterate through whatever numbers that we have in this dp. For each final int dp number, right? Dp number inside our dp set. Okay. So what we need to do is that we need to first find the sum, current sum, which is the dp number plus the number itself, right? So what we are doing is that we take first element. So right now in the base condition we have got set as 0, only 0 is present, and then we go with the nums I is 1, and then we do 1 plus 0, which is 1. So this is current sum, 1 plus 0. Okay, and then we see that whether this current sum is equal to the target, because this is our final solution, that if the current sum, whenever it reaches target, we return true. Otherwise, we keep on adding it to the dp set. So I'll check this condition. If current sum is equal to target, then immediately return true. This is our solution. Otherwise, yeah, so if this, otherwise we need to just go back down a little bit. Yeah. So otherwise we need to add it to the dp. So if the number is not, we just simply add this one to the set. Similarly, for this example, once we found we have this set in dp0, we have got 0 and 1 in our set, and when we get the fifth element, we add 5 to 0 and 5 to 1, and then we see that whether 5 or 6 they are actually equal to the target, but they're not. So we simply add this 5 and 6 back to the dp set. But here, if I try to add, like if I do dp.add current sum, right, then it will result in, we are mutating this while going in the for loop. So we can't do that. It will mutate the state of this integer, and then it will be going into infinite loop, or maybe some exception, concurrent multiplication exception. So let's do another thing. Let's create a temporary set which will store, for current number, it will store all the current sum possible and store it, and then we will add it into the dp later on once we are out of this for loop. Okay, so let me create another temp set, call this temp, and instead of adding to dp set, I will just add this. Okay, add current sum, right? And also let me add this dp number, because we have, it means that I've already consumed that number and we didn't find a target. So I will add these two. So for each of the, we iterate through each of the numbers in dp, check whether the current sum is common, the number itself and the dp number, they match to the target. If it matches the target, we got our solution and return true. Otherwise, we add that number, current sum, and the number, both of them, to our temp set. And then finally, once we are out of this for loop, once we're done with all the numbers, exhausted all the numbers from this dp set, we add these numbers, whatever we have in temp, back to dp. So do dp.addAll, because a set, it will not have any duplicate entries. It should be fine. So that's it. That's the whole loop. So this part is actually same as what we are doing for here. So our temp is actually storing all these numbers, 11 from here to here, for a particular iteration for a number. And once if it hasn't found anything, then it will add it back to the dp, final dp. And then when we move to the next dp3 element, we have already added all these 4 items in our dp set. So this is what about this loop. Okay, once we have done with this, we have exhausted all of the things, and then we have to return if the target is contained in our final dp set, right? Yes. So this is save some space again, and I think this is all about the algorithm. Let me run it first and see whether it's correct. So I will take the scan partition new int, and then I will take this from, yeah, let's take both the cases examples given here. So let's run this. I've taken both the examples from lead code and it's giving true and false, which is same as here. Now let's copy this code into lead code and submit it for covering all the test cases possible. Submit it. So it works well. We've solved this. So let's go back with let's quickly do the time and space complexity. So the time complexity would be, we are having 2 for loops. And for each of the for loop inside it, we are iterating again to all the sets. So it would be, time complexity would be O of whatever we have the sum, right? Because we are doing the sum and we are iterating through all of them. So anyway, I will just I will take the average case, so it would be O of n square, right? And for the space complexity, because we are creating 2 dp sets, and it would be the sum of the numbers. So it should be O of, again, n square. I'm just taking the the generic case. It would be actually the correct would be the sum of the nums that we have, square of it. Okay, this is the time and space complexity for this algorithm. So anyway, so this is all about this problem. So this was all about partition equals subset sum, which was our 13th problem. In the next video, we will solve the 14th problem of our tutorial series on dynamic programming, which is counting bits. This is another very interesting problem to solve. See you all in the next video.